This next video is going to be super duper short because it is just the second method of solving a quadratic equation, which is the principle of square roots. The principle of square roots is that anytime you have an x squared, to solve for x, you do the opposite of squaring, which is taking the square root. When you take a square root, you just have to be aware that you always get two answers. You always get a plus and a minus. So for example, think about the fact that we just solved this question on the previous page. Okay, we just solved x squared equals 81 by factoring, and it was a difference of squares, and we got x equals plus and minus 9 as my solutions. If I use the principle of square roots to solve this, really what I'm doing is I'm solving algebraically. So I'm trying to get x by itself. The opposite of squaring is taking a square root. What I do to one side, I'll do to the other, but I have to remember that it's just plus or minus. So if I solve by taking the square root, I would get plus or minus the square root of 81, which 81 is a perfect square, so I get plus or minus 9. So some might not argue that this is way easier than solving by factoring something like this, and I agree, but you have to remember the plus minus, otherwise you're losing half of your answer. So again, if you think of solving the principle of square roots as solving algebraically, we're trying to get x by itself. So what do I have to get rid of first? The minus 10. So I'm going to add 10 to each side. You end up with 2x squared is equal to 10. Then I'm going to divide both sides by 2 so that I can isolate my x. Then I'm not solving for x squared, I want to solve for x. So I'm going to take the square root of both sides, and when I do, I'm going to put a plus minus. Now this question said give exact solutions, so I'm not going to touch a calculator. I'm going to give a radical answer in its simplified form. So there's no perfect square that divides evenly into 5, so that is my final answer. All right, two more. For this next one, I have x squared is equal to, or x squared plus 13 is equal to 0. So the first thing I'm going to do is minus 13 from each side. I end up with x squared is equal to negative 13. Then again, the opposite of squaring is square rooting. So I'm going to take the square root of each side, and I'm going to make sure I put that plus minus. I'm left with plus or minus the square root of negative 13. And then I have to simplify this radical. We're going to write it as plus or minus the square root of 13 times the square root of negative 1, which is going to leave me with plus or minus root 13i. Awesome. Last one in this set. Can this one be solved algebraically? Well, if you think about it, I'm going to reverse all the operations. If I was to get rid of this 5 first, I would add 5 to each side. Then I'm left with x plus 3 all squared is equal to 5. Could I then remove the squared and get into this bracket to solve for x? Yeah, so I'm going to keep solving algebraically. To get rid of the squared, I'm going to take a square root. When I take a square root, what I do to one side, I do to the other, and I have to remember the plus minus. And then lastly, I'm going to get that x by itself, so I'm going to minus 3. When you do that, always write the minus 3 out front. So it's going to be minus 3 plus or minus root 5. So it's not that it's wrong if it's plus or minus root 5 minus 3. It's still going to give you the same answers. But we're going to be learning two more methods for solving quadratic equations, and one of them is going to be the quadratic formula. And so what we do is we kind of just write everything in the form of the quadratic formula. So that if you think about it, you've got this coefficient or this constant out front plus or minus a radical. So then we're going to write this as a constant plus or minus your radical. Awesome. Go and try some of those.